Welcome back to AP Statistics with Mr. Walton. Today we're going to review Chapter 7, Sampling Distributions. For our first two examples, we need to identify the population of interest, the parameter, and the statistic. So please read our two examples and then, miraculously, before your eyes, you shall see the answers appear. Hopefully you're working. Okay, so hopefully now that you're looking at my answers that have been put up, you can notice that I have made population and parameter the same color, statistic a different color, so that we can remember that parameters are any numbers that describe our population. That could be a mean, that could be a proportion, that could be a standard deviation, that could be a median. It's not limited to just means and proportions. Okay, so don't forget, standard deviation, that's a statistic or a parameter depending on, is it describing my population, population P, parameter. Is it describing my sample, sample S, statistic. All right, so hopefully you did well. We're moving on. Sampling distributions, how do I tell them apart? We've got a graphic organizer, so please remember, we have either a sampling distribution for proportions or for means. We're always going to use our center of the sampling distribution. The mean of all possible p-hats is equal to p, okay, the mean of all possible x bars, that's the mean of all sample means, will be equal to the mean of the population. Then we have our two conditions. Notice the first condition is the same for either proportions or means. It's called our 10% rule. Is it reasonable to say that our sample is 10% or less than the size of the population? Or is 10 times our sample, okay, we say we have a sample of 60, 10 times that 600. Is it reasonable to say that it's at least 600 in our sample, in our population, sorry. Condition 2, if we're in proportions, this is where it differs. We've got to say this is true. You must show your calculations. Or we're on the other side, we have our central limit theorem and we write it out, or it will be given that the population distribution is normal. So make sure you keep track of that. And then don't forget, since we're talking about a sampling distribution, that we have two different calculations for our standard deviation. And as a reminder, okay, on the green formula sheet, page 2, second page. All right. Also, the means are listed there as well, so you don't have to worry about it and forget. So in section 7.2, we were talking about proportions. So here's a practice FRQ. Read carefully, and then you're going to see in a few moments my answer. Ready, go. All right, so you write our summary stats, what we know. Also realize that this standard deviation is calculated after I understand that my condition has been met and that we're going to use our beautiful normal approximation after I show that it is appropriate to do so. All right. For section 3, we have another problem. So let's read this and try it. Ready, go. All right, and here is the work for our mean problem. Hopefully it's not too mean to you. So notice this time we're using the central limit theorem because n is greater than or equal to 30. So the sampling distribution will be approximately normal. And I said it's reasonable to assume that there are more than 2,500 men in our population. Therefore, it's okay to calculate our standard deviation. All right. So Hopefully this worked out for you. You have a nice conclusion in context. These are all the parts that we would want to see in any FRQ, whether it's me or an AP grader. Now let's look at some practice multiple choice. Okay. The variability of a statistic is described by... Everybody knows. You're going to read carefully. Boom. Okay. 2, we look at our dot plots, the statistic that has the largest amount of bias, meaning most deviation to one side. And I think that's fairly obvious in that it is C. Remember, bias is consistent on one side. Here we go. Number 3. According to a recent poll, 27% of Americans prefer to read their news in a physical newspaper instead of online. Not a lot, I guess. Let's assume this is the parameter value for the population. If you take a simple random sample of 25 Americans and let p hat equal the proportion in the sample who prefer a newspaper, is the shape of the sampling distribution approximately normal? Remember, that's n times p, n times 1 minus p. If we check 0.27 times 25, nope, nope, and nope, because of this. Number 4, the time it takes students to complete a statistics quiz has a mean of 20.5 minutes, standard deviation of 15.4 minutes. Large variability there, right? What is the probability that a random sample of 40 students will have a mean completion time greater than 25 minutes? Okay, so now we're talking about a sample of size 40, so we have to change our standard deviation. We're looking at a probability statement. We're using normal CDF, and hopefully you have calculated it to get B. Next up, fair coin. Excuse me, is tossed 60 times. N is 60. The probability that more than 1/3 of the tosses are heads is closest to... Hopefully we get this. All right. The histogram below was obtained using 750 high school basketball games, right? So we're looking at this. What is the range of sample sizes a researcher could take from this population without violating, right, our conditions? Now we're looking for a mean number. So what's the minimum we need? 30. So automatically, can I deduce that no and no? All right. So the smallest number I can have is 30. Now, what is the other piece that we should remember? 10% rule. What's 10% of 750? Right? Everybody's got it now. Boom, boom, boom. Yes. You're hoping I ask one like that, I know. Number 7. We're looking at incomes in a certain large population. And we want to talk about what we're going to do. What's the probability of the average salary exceeding $65,000? So remember, sample size is 4. Bam. Okay. For number 8, if we're going to use this, what changes since we're talking about a sample? We have to change our standard deviation. We have to divide by the square root of 25. So 10 divided by 5 is 2. So our answer is B. Alrighty. Number 9 and number 10. Okay, here we go. We have scores. We're looking at a random sample of 36. 36. What does that mean? 36. Bing, 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 bing. Central limit theorem. Our sampling distribution will be approximately normal. Number 10. Again, we have a simple random sample of 100. 100. So now we're looking at changing our standard deviation for the sampling distribution so that we can calculate appropriately, and hopefully we get C. Remember, you guys, stop this at any time so that you can work these out ahead of time, right? Or go back and retry. Here we go. A little bit of help here. Do I know these things? Got it. Almost there. Needs work. If you can do all these, you are ready for the test. If not, study. Ask your friends. Come and see Mr. Walton. Good luck.